So let's work on problem 6.2.14. They want us to find power, 3 ohm resistor, and then energy. So let's find the power and the energy for inductors and capacitors. And this is under DC condition. So what we need to do, inductors is going to be what? Short circuit. So I'm going to just let IL1, and then capacitor as an open circuit, IL2, and then this guy is going to be VC. When I let this capacitor as an open circuit and VC, since there's no current go through here, so this 4 ohm resistor is doing nothing, right? So we don't have to even bother with this 4. So I'm going to just call it VC plus minus. So our objective, our job is to find the VC, IL1, IL2. That way we can put it into W equation and find the energy in joule. So now what? What do you want to do? We already found the IL2, right? IL2 is opposite of this guy. Therefore, I'll just write IL2 equals to negative 6M. Done. All the time in chapter 6, chapter 7, under DC conditions, the current direction of the inductors always go from left to the right, top to bottom. If there was inductors somewhere in here or here, then IL direction should be downward. So what do? Mesh analysis? Okay. We need to do mesh this guy. I'm going to call it actually, we can call it I1, but this is actually the same current as this guy, right? So I'm going to call it IL1 as this. Mesh 1, we have negative 12 plus 3 times IL1 plus 6 times IL1, and the current, this loop is in that direction as a 6, right? IL2 is a negative 6, but I'm just using this current. Therefore, IL1 is the same direction going downward, so it should be plus 6 equals 0. So we have 3 IL1, 6 IL1, 9 IL1. I'm going to move this guy to the other side, equals positive 12, and from here minus 36, that is negative 24. So IL1 equals negative 24 over 9, negative 8 over 3 M. So we found IL1, IL2. Now how you find the VC? Yeah, all right. We don't have to do anything. The voltage across here is the same as voltage across here. So VC equals 12. So the voltage across here, same thing as voltage across here, same thing, until we hit this guy. They're all 12 volts. P in 3 ohm equals to V times I. And we can find the voltage, or V equals to IR. So I squared times R is also fine. And the I is IL1, this guy, IL1. So that is, where is our IL1 we said? Oh, negative 8 over 3 squared times 3 ohm, 64 over 3 watts. And then W IL1 equals 1 over L1, 1 over 2L IL1, negative 8 over 3 squared, WIL2, 1 over 2L2, 3 IL2, negative 6 squared, WC, I'm sorry, I should just write it, WL1, WL2, WC 1 over 2 times 2 VC 12 square. So that's 144.54. Oh yeah, thank you. Yeah, energy stored in L1, energy stored in L2, energy stored in the capacitor. Inductors, we need to use currents. Exactly. So the formula, I'm sorry, I forgot to put it there. So the formula W L equals 1 over 2 L I squared. WC should be 1 over 2 C VC squared. Yeah, oh, okay. Well, under DC condition, since we're gonna make it open circuit, so there's no resistance at all. So we just calculate the energy across the capacitors only. Next, one more. Okay, now under DC condition, we're gonna have this 3K. So I made an open circuit for the capacitor, short circuit for inductors right there. So what do we do? Okay, we can do that. So what's the current go through this 6K then? It's gonna be IL, right? So using IL, do the KVL here, KVL there, negative 12 plus 6K IL plus 2K, and this guy we need to say I0 equals to 0. When you do KCL, I'll just write it. So when we do KCL at node A, we have 2 milli plus I sub L equals to I sub 0. When we plug it in here, 6K I sub L plus 2K 2 milli plus I sub L equals positive 12. And I of L, 6K and 2K, 8K I of L equals 12. We multiply minus 4 equals 8. I of L equals 1 milliamp. So we can find the energy in the inductors. What about VC? Great. This is 8 milli, and here's the 2 milli. Therefore, going down is a 6 milli. So the voltage across here, we just call as plus V1. Then we have V1 equals 6 milli times 3K, which is 18 volts. And then we're gonna do KVL in the loop. Then we have a negative V1, which is negative 18 plus VC plus 6K times IL. The IL we have is going up, upper direction. Therefore, we have plus and minus right there. So the voltage across here should be minus. So I'm going to write minus 1 milli. Miss that. And then plus 12 equals to 0. So now VC equals positive 18 minus 12 plus 6. So that is negative 6, 12 volts. So now WL equals 1 over 2, 1 milli, 1 over 2, L1 times 1 milli square. So it's a 0.5 microjoule. And the WC equals 1 over 2 C 10 times 10 to the negative 9 nano. And then voltage V 12 square. So 144 divided by 72 times 10 times 10 to the negative 9. So that is a 7 20 nanojoule.